In trigonometry, we're going to look at angles of elevation. Angles of elevation or angles of depression, which is a different subject, are important, and they are measured with respect to the horizon. So when I'm talking about an angle of elevation, I'm going to simply draw my horizontal. Now my horizontal is just a line that is flat to the ground. And if I always look at it like this, so here's me, and if I'm looking up, this is the angle of my elevation. So angle from the horizon up is angle of elevation. So we can there's more than one horizontal plane. So there's an infinite amount of horizontal planes. So sometimes you just have to pick which one works best for you. But that comes with experience. Circle the angle of elevation in this diagram. Well, here's my line of the horizontal. The angle that is measured above the horizontal is this one right here. So it's 15 degrees. 2. Write an equation that would allow you to calculate the angle of elevation. Well, again, my angle of elevation, I'm just going to make, here is a horizontal line. And if I notice my angle of elevation, if I want to, there's my angle of elevation. It's an angle above the horizontal. So how can I, for example, create an equation? Well, quite straightforward. If that is theta, this would be my hypotenuse, and this is my adjacent. Adjacent and hypotenuse, we're talking about cosine. So cosine theta is equal to my adjacent over my hypotenuse. So if I was to create an equation, the equation would be cosine theta is equal to 29 over 33. And that would satisfy me. I mean, some people may want to take it even further and just simply isolate theta to one side, and that would be the inverse cosine of 29 over 33. All right, example 3. I guess we're going to start earning our money very shortly. Example 3. Danny builds roof trusses for a construction company. Most people call trusses rafters, I think incorrectly. I don't know, I'm not a construction worker, I'm a math teacher. Anyways, he needs to cut a ridge beam at an angle to attach it to the rafter. I don't know what a ridge beam is, but if I look at the picture, it looks like the ridge beam is these beams at the bottom, maybe. And my rafters are here. So here and here, I guess that's what I'm talking about. The cut angle must match the angle of elevation of the rafter. Oh, fair enough. Or X degrees. What angle should Danny cut the ridge beam? Well, here it's really giving us the angle of elevation. But our ridge beam is this piece of wood right here. One would presume it's wood. It's horizontal. And if we go above the horizontal, X degrees would be my angle of elevation. Now, if I take a look at now I always have a hard time with this, by the way. I'm going to put 6 and 12. When I take a look at a picture, it's really confusing. So an important part for me is to make another picture that simplifies the argument. I know the height of this is 6. My ridge beam length is 12, and I want to find X. Now, X is a valid variable for an angle, so I need to calculate X. So I can forget about this complicated picture of construction, and I can reduce it or simplify the problem. When I take a look and I want to find my angle X, this side is opposite, this side is adjacent. So I go out and reach what trigonometric identity or what trigonometric ratio is opposite and adjacent. Well, that's tangent theta. Now tangent theta is equal to opposite over adjacent. It would be TOA. So tan theta is equal to 6 over 12, or theta is equal to inverse tan 6 over 12. And what I get is theta is equal to 26.565 degrees. And that's angle of elevation. It is an angle that is above